Thanks again for joining us. This is our third monthly Hedera Engineering Insights webinar. I'm Garrett Coons, a part of the product marketing team here at Hedera Hashgraph. And with us today, per usual, is Donald, and he is Director of Product Management, and Greg Scullard, our developer advocate. We have some exciting updates in version 0.9.0 of our Hedera services code. Some of these things include the new Hedera Token Service and its availability on testnet. We have a demo and updates on version 2 of the Hedera SDKs, so it should be a good presentation and talk. Of course, if you have any questions, feel free to throw those into the chat and we'll try our best to answer those. But looking forward to the conversation and hearing from you guys. You want to take it away, Donald?
Sure thing. So good to talk to everybody. I hope everyone is staying safe and getting excited for the holiday season ahead. So as Garrett mentioned, we wanted to spend the majority of today talking about the Hedera Token Service. This was recently enabled on the public testnet and is one of the services that we're very excited to get into the market, supporting both our token issuers as well as some of the users of different tokens or on-ramp providers. So what we wanted to do today is just talk through a bit about the Hedera Token Service fundamentals, but then more importantly, show some of the great demo applications that Greg and the team have put together so you can try it out for yourself, as well as where you can get the code to give that application a try as well. We're, as I said, very excited about this service and certainly want to be hearing feedback, how you want to use it, whether there's requirements or improvements you'd like to see. So please don't hesitate to reach out, as we're going through with those questions or comments. So with that, I'll just jump in, first defining that Hedera token service, and then I'll pass it over to Greg to talk through the demos in a bit more detail. So as many of you may have heard, our goal is to position ourselves as the best place to scaled adoption of tokenization for enterprise and consumer scale. Whether you're building in a permissioned or layer 2 network with the Hedera consensus service or wanting to issue your asset natively, we think that the performance, fairness, and speed that Hedera can provide, along with predictable cost and stable governance, are those key differentiators to ensure that tokenization use cases can not only start easily, be customized to specific use cases, but also scale over time. So today we're going to show how native asset issuance on the Hedera mainnet can be used to allow developers access to all of these differentiators. So at a high level, the Hedera token service allows any developer to define and issue a token onto the Hedera mainnet. Now, what that definition does is actually creates a unique token entity that can then be held by different Hedera accounts. The performance and cost profile is similar to the cryptocurrency service or how you interact with HBAR. And you can actually hold any Hedera or hold any token in a Hedera account if you opt in to do so. We chose to put in the opt-in requirement because we don't believe that Hedera accounts should be, at risk of spam attacks or airdrops of tokens they don't want to receive. But it's quite easy for any Hedera account to quickly opt into a token which they'd like to hold in their account. Now, in addition to that basic token definition, we allow developers to specify a set of programmable roles and behaviors that outline what that token actually does and who can control different behaviors for that token type. So each of the roles I'll talk through here are optional, which means they can be used or not, thus giving the token the ability to either be fully immutable or controlled by permissioned entities for different behaviors. We have an administrator who can actually manage the token, both its creation, naming, and symbol, as well as updating the token definition. We have the supply manager who can mint and burn tokens if they want to increase or decrease the supply of that token. We have the KYC controller who can flag whether a Hedera account is KYC'd or not, which, if required for that token type, would block their ability to hold, receive, or send. We have an account controller who can freeze or unfreeze a Hedera account, again, optional for a specific token type. And finally, there's a wipe controller who, if needing to perhaps enforce regulatory actions or some other correction, can wipe a token balance from a Hedera account. Now, I want to mention two specific disclaimers in this list you see here. First, we've defined each role as a single person, if you will, but each of them inherit the actual multi-sig nature of Hedera and can be multiple keys, as we'll talk about later. So there is true decentralization of these roles. And second, each of these behaviors only applies to the specific token type that's created. So for instance, somebody who freezes a Hedera account for Greg token only freezes that account's interaction with Greg token, not HBAR and not any other token type. For us, this allows token issuers to apply different regulatory controls or token controls to their token type without infringing on how a Hedera account interacts with the rest of the system. And again, I'll add just at the end here again, each of these are optional. So it's free to use or it's available to use, but not something that by any means must be used. So the journey starts in that definition transaction. You'll see Greg walk you through this shortly, but it allows the developer to specify a name and symbol, which can either be used to name the token or to reference some additional data, as you'll see shortly. It allows you to specify the decimals by which it's divisible, the admin keys, the supply manager keys, the freeze keys, the wipe keys, the KYC keys, and also the initial supply of the token that's created. The definition also specifies a treasury account, which is the Hedera account ID, which would receive minted tokens, and also allows the developer to set a flag of whether or not the token is default frozen for all Hedera accounts which associate or default not frozen. What that means is you can choose whether you want to enable more of a whitelist model or a blacklist model for your token. And finally, token entities, like all other entities on the network, have relevant expiry information that ensure they maintain in state over time. I mentioned previously before, but again, one of the big differentiators of Hedera that applies to the Hedera Token Service is that you can have either single keys, key lists, threshold keys, or nested key structures to manage these different roles and behaviors and the ultimate token entity. So you could have one user with a single key that controls that Hedera entity, or you could have multiple parties who are required to sign transactions to interact with that entity. And that can be coordinated with either an application network or a layer 2 solution to have true decentralization for any type of application. You can even potentially use contracts to manage that multi-sig process. So whether it's automating a money market based on some layer 1 transactions, managing collateral for a token that's issued, or issuing things like NFTs with a standard template for multiple parties, there's a whole multitude of use cases for how this layer 2 can interact with the Hedera token service. And really the list is ever growing. So you can have a token ID that's unique, which supports a non-fungible token or class-based token, similar to ERC 721 and 1155. You can also create a supply within each token ID that's fungible with one another to support many fungible token use cases. You get to transfer Hedera, the token between Hedera accounts, similar to how HBAR is transferred, meaning that there's separation between the fee payer account and the account that's transferring the token. So you could actually have a user not even need to be aware of HBAR. But it can also do a lot of cool features, not only like multi-sig, which I mentioned previously, but also atomic swaps of multiple tokens in a single transaction. And you'll see that in the demo as well. So I'll make sure to leave you with these links, which you can find either at docs.hedera.com or at hedera.com. And that's the link to the documentation for using the Hedera token service, which again, I mentioned is ready and available on the public testnet. Or if you want to think about the actual architecture of the service and how we think about tokenization in general, feel free to read our white paper, which is available at the right here. So I'll keep an eye on any questions that come through in the Q&A. But I'm now going to pass it over to Greg to talk through the demos we've created for the Hedera Token Service.
Thank you, Donald. So hi, everybody. And as Donald says, hope you're all well and getting ready for presumably a well-deserved break in the weeks to come. So you may have seen this demo in the webinar that I did with Cooper a few days ago. It's been improved a little bit since, so we'll go in a little bit more detail on some of the new features in the demo. I'll go back to GitHub after I've done the demo, but all the code is fully available and open source within our GitHub repository. So let's start off as the owner here of a token. So this is the account ID, and this is on testnet. So if you have Dragon Glass up and running on your computer, you're more than welcome to follow what's going on with the demo. We're actually running this live on testnet at the moment. So I have an owner here. Alice and Bob are two wallet users. I've chosen to put them all within the same UI to make it easier to run things. So from a demo point of view, it means that the UI here, the demo has access to all the keys, which makes things much easier to do when we're doing things like sort of multiple transfers between users later on. But let's go ahead and create a token. So Donald mentioned earlier that we can create fungible and non-fungible tokens. So we'll start with my fungible token, and we'll call it MFT for confusion. It can be whole or fractional, so we'll make this one whole. We'll start with we'll go with a variable supply, and we'll start with no initial supply. We'll make it mutable, which means that we're associating a key. And again, for to keep the demo code relatively simple and the usability relatively simple, the key association that's associated with the mutability feature, KYC, wipe, and freeze, is the key of the owner account. But as Donald said, this could be different people with different keys with different roles. So we'll make it mutable. We'll ensure or we'll require KYC. We'll make it possible to wipe a quantity of Hashgraph or tokens from an account, and we'll also make it freezable. So finally, the composer here is telling me that I'm about to create a fungible token with the following properties and some hints at what it could be used for based on the IWA framework or taxonomy for tokens. So let's go ahead and create this token. So this should take only a few seconds. So as you can see, the token creation was successful. I'm automatically associating here with a marketplace account, an escrow account. I'm planning on building some features that are not there yet for a kind of token marketplace, but again, we'll see this later on. So now that I've created my token as the owner, because it is a variable supply, I'm able to mint some tokens. So I'll mint 100, and we should see the supply increase from 0 to 100. And conversely, I can also burn a quantity of tokens. Now let's just, for argument's sake, the demo does very little in terms of checking. It literally sends transactions to Hedera. So as you can see here, we have an invalid burn amount because it's higher than the supply. So let's try 20. So the reason I didn't want to put any checks and balances in the demo was so that we could see Hedera essentially controlling or making sure that the actions that we take on the token are valid. So for example, if I wanted to transfer this token now to Alice, and I wanted to transfer 5, Alice hasn't been KYC'd, or she's not even associated with the account. So as Donald said earlier, we can't airdrop tokens onto Alice's account until she's gone associated. So we'll do that for Alice right now. So now she's associated. Bob will associate as well. And then if I go back to the owner view and I now try to transfer to Alice a quantity of 10, that should, oh no, I forgot to do KYC. So as the owner, I now need to grant KYC to both Alice and Bob. You can see Hedera is keeping checks and balances on everything I try and do to keep the ledger clean. So now we should be able to transfer to Alice. So we still want to transfer 10. So let's go ahead and do that. And the token transfer has been successful. So if I go back to Alice's screen, I can see she has a balance of 10. She's no longer frozen and she's been KYC'd. What I'm now going to do, because I want to send some tokens to Bob, I'll send him 5, but I'm not so friendly with Bob, so I would like him to pay me 2 HBAR for this. So what this is doing is it's building a transaction that includes both a token transfer and a HBAR transfer in one single atomic operation. If, for example, I put a token quantity that's greater than is available from the treasury account, let's say 1,000, this would fail and Bob would not pay me 2 HBAR. Conversely, if Bob's balance wasn't sufficient, then the token balances would not be updated either. This is a fully atomic transaction, all or nothing. So if we go ahead and do that, we can now look at Bob's account, and Bob started with around 10 HBAR. He's now at 7. He's paid 2 for the token that he's just bought, and a little bit for the token association. So we can see his balance is now 5. If I go back to the owner, if I go back to all of the accounts, we can see Alice has a balance of 10, and as the owner, and because the account or the token is wipeable, I've been able to wipe Alice's balance. The demo wipes the entire balance. The API supports wiping a quantity out of the available balance. So through the API, I could have wiped 2 out of the 10. But again, for demo purposes, I figured we'll just wipe the entire balance. So we've done quite a lot of stuff here. So let's check out this owner account on Dragonglass here. So you can see that I created the account earlier today. We've created a token, we've granted KYC, we've minted the token, we've burnt the token. That failed, this one succeeded. Then we tried a transfer, we had a problem with the association, then a problem with KYC. We've granted KYC to Bob and Alice. We've done a crypto transfer, which in fact is a transfer for both tokens and crypto to Alice and to Bob, and we finally wiped from Alice's account. So that shows the actual transaction history over on Dragonglass. So what else can we do? We can return back to the tokens here, and Alice, or rather, let's go with Bob. Bob could transfer his fungible token to Alice, and he could transfer a quantity of 2. And again, he could either pay Alice 1 HBAR for doing so, or he could receive, negative to send. So he pays Alice 2 tokens plus 1 HBAR, or he asks Alice to pay him 1 HBAR. So this should transfer back to 2 tokens to Alice, and my HBAR balance has gone up to 8, and Alice's should now be below 10 again. She's associated and just paid 1 HBAR, so that's about right. Cool. So this is a fungible token. Now let's try and create a non-fungible token. So we'll call this one my cat NFT. And what we've done here in the demo is we've allowed for some templates to be created. So there is a file within the demo that contains templates for different types of tokens. So in this case, I'm going to choose the cat template. And the cat template specifies that I can upload a picture. So we'll upload a picture of a Maine Coon. We'll specify the breed, and we'll specify an eye color. If I'd chosen a frog or a card, I would have had a different set of properties here. Now, we're going to move on to KYC. By default, I say no, and not freezable either. And this just makes it easier for me to run the demo and not have to KYC every time. So we're about to create a non-fungible token called myCatNFT, which will be non-fractional with a supply of 1. Again, this is that there are some fungible tokens or non-fungible tokens, I should say, with a supply greater than 1. The demo pegs it to 1, but there's nothing to prevent you from increasing that supply to a greater amount. So we're now going ahead, and what we're doing behind the scenes here is creating a file on the Hedera ledger, and that file is an immutable file. There are no keys on it, and we can check it out on Dragon Glass. There are no keys on it, meaning that it's set in stone on the network, and that file contains the properties that I've just input: the eye color, the breed, and also the picture. So this has now essentially become the symbol for this NFT, and I can refer to it wherever I go. So if I click on details here, I'm actually pulling the file back from the Hedera network and extracting the picture as well as the breed and the eye color that we specified. And you can see all the options that we've not selected, the treasury account, which is the owner's account. And as Donald said, there's an auto renew period and an expiry date on the token. So now that I've got this NFT, again, I need to go back as Alice here and associate with it, and I will do the same for Bob. And as the owner, I can transfer this NFT to Bob, and I won't ask him to pay. Now note, because it's an NFT with a quantity of 1, I don't have to input a quantity here. So we're transferring this to Bob now. So the cat NFT is now in Bob's wallet, and Bob is able to see the picture here in the demo. Frozen is not applicable. KYC is not applicable per the token specifications. So it's kind of using this definition for a fungible token with a supply of 1, setting the properties of the token in stone within a file and attaching that to the token's symbol in order to attach the file to the token itself. Ideally, and I think I made the token immutable, and that means that the symbol for the token can no longer be modified. So I can't attach a different file with different properties to my NFT. I've now locked everything down, and that NFT will never change, besides changing owners. So let's do a little bit of swapping here. So let me just check what Alice has. So she has 2 of my fungible token. So we'll ask Alice 1 of her fungible tokens in exchange for the cat NFT, which is a quantity of 1, and we'll ask for 3 HBAR, or we'll send 3 HBAR as well. So what we're doing here is, sorry, this should be -1 here. We're asking Alice to give us her or 1 of her fungible tokens in exchange for 1 of my cat NFT token, and we're also giving her 3 HBAR. Again, this is 1 single operation, 1 single transaction. It all works or it all fails. And there we go, it's worked. I now have 4 fungible tokens. I've given up my non-fungible token, my HBAR balance updated accordingly, and same for Alice. She now has the cat NFT. She's the proud owner of that cat, and her balance changed accordingly. So I've got a marketplace icon here, or tab. This is not currently enabled, but the idea being that I will be able to specify an NFT here, the cat NFT, send it to the marketplace, which would be an escrow account. And I could put an offer for 10 HBAR, and then Bob later could come to the marketplace and essentially say that he's interested in buying this particular NFT for 10 HBAR, and then the transfer would take place. That's not currently working. Give me a couple of days, and if you check back the repo, you should find it's hopefully all good to go. So I think that concludes the demo. This button here shows me all the different transactions that we've run. These are locally managed; they're not pulled back from a mirror node. But again, if I go to the fungible token here on Dragonglass, we can see we've created it, and we can see the raw transaction for that creation of the token with. Sorry, that's the fungible one. Let me go back to the NFT. You can see on Dragonglass the raw transaction, and we should find the where is it? The symbol here, Hedera : / that represents that file ID that contains the token properties. Cool. That I think just about covers the demo. So if you're interested in looking at the repository itself, what I've shown you here is in the feature NFT branch. This will soon merge into master. It's a Vue.js application that requires there is no node component. The browser communicates directly with the Hedera Token Service using the SDK. So we have a number of different components here. A card for looking at the accounts, a view for all of the accounts, the composer dialog, which uses the fungible composer and the non-fungible composer. We've seen mint and burn. We've seen cards with tokens. There is a dialog there for creating a generic token without going through the composer. So here we can create just any token we want without going through all the composer steps, and just check off the different options that we want. That works just the same as the composer. It's just not leading you step by step. And yeah, that's showing us the list of transactions on the right hand side, and the wallet is where we can see Bob Analysis tokens, the ones they own, and where they're able to transfer to others. Then there's some other bits and bobs here of more or less interest. In service here, I guess what is probably the most important or most interesting is the token service, which implements all the API calls. So token get info runs a token info query, token create sets up all the token properties. Do we have an admin key, KYC key, and so on. It signs with additional signatures for admin and KYC, but in this instance, it's the same. So we just have the one signature. Sorry, it's the same key for all the different options. So it's just a one signature. If we had different keys for wipe and supply, we'd have to sign here with every single one of those additional keys. Then we create the topic, or the token rather, and return that information back to the client. And this is for the marketplace. So this does an associate. If the token has KYC, it grants KYC, and eventually unfreezes if it's a freezable token with a default free status of true. We can see here, so this is a generic method for doing a token transaction with an amount of HBAR. This is just for reusability purposes. So down here we have the token burn operation, token mint operation, token wipe, and so on and so forth. So this is really where all the APIs are called. And I think the demo covers all of the available APIs on the token service. And just one last thing before we go to questions. If I go back here into public, this is the file that defines the templates for the different tokens. So you can see we looked at, let me go to the cats. So we have a photo property, a breed with a list of values, and an eye color with a list of values. And if I scroll back up to frogs, the frog token again has a picture, but it has skin color with different types of different color skins, what size it is, and whether it's dangerous, from slimy all the way to lethal. So with that file, you can look up this this specification for this component, and you can build up any specification that you want for your token without necessarily going to mental. There's presumably some limits to what can be done and what needs to be done, but yeah, that's the demo code. Donald, any questions?
Yep, thanks, Greg. Maybe I'll just address some of the questions that were asked. You on that last screen showed, I think, the file or the reference file, and essentially how any different URL could be put into that symbol field. So somebody was asking about constraints of that file structure. So I think it's just worth mentioning, in this demo we showed the symbol entered as a reference to the Hedera file service, which results in a use of that service and its associated pricing and data structure. But you could use anything else in that symbol field, whether it's a DID, a URL, or some reference to another source of data. Ultimately, it's kind of configurable for different uses.
Yeah, absolutely. I mean, the file could be stored on S3, and the symbol could be a hash of that file. Any way to essentially ensure that wherever that definition exists can be verified back against the NFT to make sure that nobody's gone and tampered with the cat and changed its breed, for example.
Absolutely. There was also a question just about availability. So as I mentioned, it's available on the public testnet now, and we'd probably target mainnet availability in Q1 of next year. There was then a question about the use cases. So I mentioned a few on earlier slides, but really it's kind of an ever-growing list of anything from stable coins to rewards and loyalty points. It could be governance tokens, it could be digital collectibles, or even more regulated securities. So we've already seen a pretty large list of use cases just ourselves, but I'm confident the use cases can grow even beyond that. And then there's one question I wanted to answer live about the difference in tokens using the Hedera Consensus Service versus the Hedera Token Service. Now, some of this is outlined in our white paper where you can get a bunch more detail, but I'll just address briefly here. The core value proposition that Hedera Consensus Service provides is transaction ordering and message synchronization for an application. Now, if you're issuing a token in that application and you want to replicate your ledger across a number of nodes, we call those kind of layer 2 nodes or application network nodes staying in sync with the Hedera Consensus Service. And the core difference is that the ledger of accounts, balances of their tokens, and any contract which manages those tokens is confined only to those node operators in layer 2, but ordered in a fast, fair, and secure way with the Hedera Consensus Service. So Hedera in that scenario provides transaction ordering and that trust model for the network, but does not store that state or the specific token and its contract. If you issue your asset natively to Hedera, then it can interact with all Hedera accounts, as well as have transactions maintained and state maintained by the actual Hedera mainnet nodes for transaction ordering, but also updates. So it's a bit different model in terms of degree of control. So we see those controlled use cases where you want maybe a specific set of entities operating your node, or perhaps a more complex contract managing your code being the best use of the Hedera consensus service. Now, I'd love to just wrap up on a few other things, and we'll keep an eye as any more questions comes through. But Greg, thanks so much for the demo.
My pleasure.
Let me steal the screen share here. So again, apologies in advance for a bit of our wonky cadence as we prepare for the holidays, but a few things I wanted to make sure to mention in closing. So here you can see the release notes for our 090 release, which is what's currently on the Hedera mainnet, including that alpha implementation of the Hedera Token Service and a few other changes around those services code. So you're free to read and see that release tag in GitHub, as well as look at the issues we're working on for 010. Just strategically, so you all are aware of our thinking. 010, especially because we want our team to have a holiday, is more focused on some bug fixes, improvements, documentation, and the like. So you won't see as many major features released right before Christmas, but that's all pretty much so we can focus on bringing some of the good stuff in next year as well. I did also want to call out 2 additional updates. So first, the Hedera supported SDKs recently released version 2. So that's for Java, Go, and JavaScript. Each of those languages, as well as our community.NET SDK, is supporting the Hedera Token Service. And you can get access to the documentation at our docs page and configure your network, set up all of the necessary account information, and make any other transactions you might need to for your client application. So I'd encourage you to check out the samples and walkthroughs there to start using version 2 of the SDK. And last but not least, we actually also had our latest HIP that's gone through the whole approval process and towards implementation, submitted by none other than our co-founder, Dr. Baird. And essentially, the Hedera improvement proposal allows the ability to have an address checksum format, so that client applications like our mirror nodes, SDKs, and wallets can verify account information when it's being entered, so you can avoid somebody fat fingering an account ID. So I'd encourage you to all go take a look at that issue in our Hedera improvement proposals repo to see the design, some of the discussion that's been going on as well, and feel free to leave a comment. In addition to that, if you have other requests, requirements, feedback, or improvement proposals, don't hesitate to drop an issue into any of our repos or reach out to myself or the team to share your feedback. So with that, I think that wraps it up from our perspective. I hope everybody has a great holiday season from me, and I'll pass it back to Garrick.
Yeah, thanks so much for that. I think that was super informative, and we answered and I think asked some good questions along the way. I don't see any other questions here in the queue, but if anybody does have a last chance to drop those in, we're very much excited for Hedera Token Service, and I'm really excited to see the HIPs. That's really cool. This is an open source community project after all, so neat to see that coming to life and some community involvement. And I think with that, we should be wrapping things up. As Donald said, happy holidays, everyone. We hope you stay safe and have a great time as much as you can. Take care.